this?
Yeah, that was most good.
Okay. So I think object-oriented concepts, you need to know some concepts like this. Different concepts like class, object, instance, method, message passing, inheritance, abstraction. I think these are the different features of object-oriented programming. And I think they're also, at this point you don't need, but in future you will need these things. And one other important concept is refactoring. You will need to know later. And here I just initially tried to describe what do you mean by object-oriented programming. Okay. So as you read, I think I tried to talk about some applications like billing software, library management software, hospital operation management software. I think each of the software, what it does, it serves some purpose, and in the software they try to implement the real world activities. Okay. If there are no software in the library, what they would be doing? They would be doing the work manually. Okay. So different person would be involved with different sorts of operations, and different objects are involved with them, like the books and those kind of stuffs. So what a library management software does, I think it imitates all the operations that a normal library management system will work. Okay. So it represents all the objects and represents the interactions between them. Like, for example, in library management software, you see there is a librarian, there are the books, and there are the students, and there are the bookshelves. Okay. So whatever you do, they involve these things. A person lends a book, returns a book, the librarian assists him to issue a book. So when you will design the library management software, you will also think in terms of these entities. Okay, this is the librarian, this is the student, this is the book, this is the author, this is the bookshelf. Your software will have all these different objects. Okay, and then what will happen in the operations, these objects will interact, and this interaction will maintain in some information system that this book is returned, or this book is lended out, or these are the new books that came into the library, or these are the authors for these books. You need to maintain those information, and also I think all the operation, I think from the surface you can think that there are different objects, they are interacting with each other. That's how the software is progressing. Okay, so that's the main concept in object-oriented programming. I think we want to see high level, not in the low level or not in the basic level. We just want to think that the software is about different objects and their interactions. Okay. And previously, what was happened before object-oriented programming, we did not think stuffs as a objects. We just thought, okay, we need to. We thought stuffs like in terms of operations or activities. Okay, we used mainly variables to represent different activities and the different states. Maybe what we could do, we could define 10 variables to identify a student. When a student just lended a book, what we could do, we could update those 10 variables, that this is the ID, this is the name, this is the address of the student, and he has lended this book. So we kept that information. I think still there were an object concept or a student concept, but it was not explicit in the software. In the software there was nothing we are calling that this is the student or this is the librarian. What we kept? We kept variables, okay, to identify the books. Let's book title, author, or book edition, year, price. Okay, we identified different variables, but we did not say that this is the book thing. But in object-oriented software, what we will do, in the software we will define, okay, this is a book and it has different attributes. Just grouping book-related attributes into one group, booking student-related variables into another group, and each of the group becomes a variable. Each of the group. Okay. Previous what we would be doing for a book, we told
different books, variables.
Yeah, grouped into one.
Okay.
I'm just telling it. Before object-oriented programming, what we would be doing in library management software, we would be giving 10 variables to identify a book, and also some other variables to identify the status of the book. Is the book in the library, or it's just recently returned, or somebody has borrowed it. Some variables to keep the status, some variables to identify the book. Okay, so there was nothing explicitly that this is the book, but there are some variables that maintain the identity of the book and the status of the book. But in object-oriented programming, what we'll be doing, we'll be telling that this is the book variable. Okay, this is explicitly book variable, but it will have different attributes or different sub-parameters, sub-variables that will keep the information about the book and also the status of the book. Another thing is, all the activities related to book will also be a part of the book variable. Okay. Previously the operations are completely separate of the objects. Okay. But in object-oriented programming, what we try to consider everything in terms of object, and we try to group them together. So what an object will contain? An object will contain some variables. Object itself is a variable, and we can say the sub-variables to maintain its status and identities, and it will have some functions associated with it to maintain the different activities on it, like borrow a book or return a book, or for students it will also have this kind of stuffs to keep the identity of the student and the status of the student, maybe which year he is in, and still he is a student or not, or he has already passed and he is an alumni and also a member of the library. So to keep his status and also to keep his identities, and to define some activities that are involved with the student. Students will be taking a book for 7 days or 14 days, or he will be returning. So there are some stuffs associated with the student, and as we are considering in terms of object, so we're keeping all these things, the identity variables, status variables, and all the operations associated with the student, grouping them together. Okay, and we will call this total variable as a student variable. Okay, so in that case, then what a programmer will do, first he will define all the different objects in the system. Then he will try to define some other objects that will define the interactions between these objects. Okay, and then I think when the software will run, I think the interaction will happen on these objects. And another thing you can say, maybe in game software, that in car racing, you can also think about it as a object-oriented programming. What do you think in a car racing program? What are the stuffs? Different cars, different models of cars. And each car has different attributes, different speed limit, or different features. Okay, and also the driver, he is also an object. You can think of different drivers or different players. If it's a multiplayer game, so you have to define different players, and each of the player will have different attributes, or some way they will be different. At least their name will be different, their identification will be different. Okay, and the runways or roads, you will also consider that roads, it's another object. Okay, and different light posts or different obstacles in the road, you can also think those are different objects. So when you will write a car racing program, what will be the first step? First step will be, in object-oriented programming, identify all the objects. Okay, you have to identify all the objects and define them. Then you have to identify, I think in case of identifying, you have to identify first the identities and the status and all the operations associated with them. Then you have to define some other objects that may represent the interaction rate. When a car will hit an obstacle, what will happen? Okay, for that operation, it can be part of the car object, it can be part of the obstacle object, or it can be a different object. It will depend on the situation. what I am trying to say, that you will think everything in terms of objects and object interactions. Okay, but in the previous procedural programs, what would be happening? There will not have any concrete or explicit object concept there. It will be just variables. Based on the situations, you will be updating the variables, and there will be different functions. Based on the situation, you will be calling those functions, and they will be doing some operations. But in object-oriented programming, we are keeping those things integrated into one thing. Another thing is in object-oriented concept. Another concept is the event concept. Event is like I think in car racing, when you press the brake, or when you move the steering, or when you press the accelerator. These are different different events. It can be associated with the player, it can be associated with the car. I think it will depend how you want to what you want to do in the game. Based on this, I think just from the surface level you can think. So I think in Visual Basic program, you also program the stuffs with in object-oriented concept. If there is a form, you put the text box or button or different stuffs. So when you select a button, you see on the right side or left side there are some properties. These are variables associated with the object, and when you click a button, you see a code view. Can you remember or not?
The code?
Yeah. When you click a button.
Yeah.
Yeah. This is the event associated with the button.
Yeah. Okay.
What will happen after the button click? You write the code in the function. I think that's the method, and you write the code. So in object-oriented programming, I think the events are mapped into or expressed in terms of the different methods also. Okay, so I'm just trying to say this is how object-oriented came. These are the three stuffs. And okay, what is the difference? As I told, we try to think in terms of variables, and based on the situations, we think in terms of operations in procedural programming. But here we think in terms of object. Everything, whatever we do. Okay, and as I told that there are other concepts like object-oriented programming. One concept is inheritance. Okay, one of the concept is inheritance. Right. I think when you write the program, I think to better design the program or to write the minimum amount of code, what you can do, you can simplify the object identification or object defining. Let for example, in car racing program, you will have different sorts of cars. Okay, or in aircraft simulation, you will have different types of aircrafts. Okay, or if you want to simulate a zoo, okay, you will have different kinds of animals there. Or in a shooting games, you will have different kinds of ammunition there. Okay, and another thing is all these different ammunitions or all these different animals or all these different cards, in the basic form they are all the same. Okay, different models or different stuffs, whatever you say, in the basic form they are same. Then we add some different features or different capabilities to identify them in different ways. So inheritance, what it tries to say that it's a good design. First you design identify the basic object, and then you add everything on top of this. Okay, so right. In case of animal, you can define an object just called animal, and then to define a dog, you can define another object dog that will contain all the attributes of animal and some extra attribute that make it dog. In aircraft, you can define a basic aircraft. What a basic aircraft will contain. There will be some wheels, some wings, some engines. It will be some default thing for an aircraft. But if you want to say a I think fighting aircraft, it has to have some other capabilities. It can throw bombs, or it can throw missiles. Okay, it will have different attributes. So in case of those kind of games or those kind of software, what we'll do, it initially define the basic aircraft, then we will define different other aircraft, and those aircrafts will also contain all the capabilities of the basic aircraft. Okay, so in that way you are saving some coding. If you are writing like all the aircrafts independently and completely, then you would have to, your code will be bigger. Okay, but if you define that this is the basic aircraft, this is one level after aircraft, yeah, one more, and then what can happen, you can add some other stuffs, you can do it another thing. Okay, maybe for the car, this is the car, you add something and you are telling it is from the Civic DX, you add some more stuffs, some more attributes, and telling it's another object on the LX. Okay, so I think one step is that inheriting another stuffs. Something is, sometimes it is a sequential. From one object you get the second object, from second object you get the third objects, from third object you get the fourth object. But another thing will happen, from the first object you get a different kind of second object, and there will be another line. So in that way, like fourth object, it is getting all the properties from first object to third objects. If you wanted to write it down, the fourth object and third object, second object, first object, all different objects, then you would have to writing more codes. Okay, so for better designing purposes, you just say define the basic steps and then inherit the properties, functions, and go to the different concepts. Okay, this is called inheritance. Okay, so this is what I tried to say. You can define the basic aircraft, then you can define some properties and some other functions to create another aircraft. Right. You can write an aircraft class initially. I think MiG-16 will be some flight military aircraft. Okay, so this is calling inheritance. There is a similar concept, abstraction. Okay, so inheritance and abstraction somewhat similar, but still there is a difference. Abstraction, or we can say it's just a template, you can say. You understand template? When you write some resume, you are given a template. Based on that, you are creating the resume. So in object-oriented programming, you can also create some abstraction of some object. Okay, right. You can create an animal abstraction. You are telling, okay, this should be the, this is what we mean by animal in our software. Okay, I think you will not represent the exact animal. It can be some different concept. I think you have to define what do you mean by animal in your software, what do you mean by aircraft in your software. Or you can say that, okay, this is the prototype, or this is the template of aircraft, or this is the template of animal in our software. Okay, so what is the advantage of this? When you define the template, then all the programmers will be working on this. If you say, okay, this is the template of the aircraft, so they will know, okay, when they want to create an aircraft, they have to follow this basic aircraft. Okay, so we can in abstraction, right, what I can say, as I was telling, an object-oriented concept will be defining an object, and in the software there will be real existence of the object. Okay, in inheritance, the first basic object, it can also be a practical object, or it can explicitly exist in the software. But in abstraction, when you are telling, okay, this is the template of the animal, this template will never exist in the software. It will be just a template, it's just a concept. You are just telling this is the concept of the aircraft, this is the concept of the animal, but you will not have any aircraft object or animal object based on that template that will be interacting with the user or with anything. Okay, but if you tell that this is the basic aircraft object, or this is the basic animal object. You can have a real existence of that object in the software that will be interacting with others, with the users, or with some other objects. Okay. And another thing, one aspect can be let. What can you do in abstract? You can say, okay, this is the animal. You will define the animal has to have these variables. The animal has to have these of the properties. These are the functions. Okay. Then what you can say, you can create another class or another object animal that will be based on this animal template or animal abstract class. Okay. So that it will go, and then from the animal basic object or basic class, you have to inherit the basic animal to get other objects. So this is the main thing. And how it will help? Sometimes it helps, I think, when the different objects are similar in some way. I think the same concept inheritance. What you can do, you can just define the template in the beginning, and then you can define the object and go from there. And I think I have provided a link here. This is the basic difference between abstract class and inheritance. So the main thing is it just works like a template, and abstract class cannot be instantiated. I think object and class, these are similar concepts, related concepts. Object is the real entity. Class you can see, class is the template for the object. Okay, class is the concept. Object is the some real existence in the software that will interact with other stuffs. I was telling abstract class cannot be instantiated. Instantiation means that creating the object based on the class. The normal class that can be instantiated and that can create the object, that will have operations in the software. But if you define abstract class, you cannot create any object based on this abstract class. But if you use inheritance based on the basic object or basic class, you will be able to create objects. Okay. Another thing is you can read this. Answers different object-oriented related concepts or different Java-related concepts. Okay. So it will help. I think I will cover most of the stuffs, but still it's better that if you know the questions or the corresponding answer, it may help in your quizzes or assignments, rank exams. They may give similar questions there. Okay. I just copied that from there to here. And another concept in object-oriented programming is polymorphism. Okay, polymorphism, you know what does it mean? Basically, the same thing, it is having different forms, okay, or the same thing, it is working as a or providing different functions or those kind of stuffs. Like I can explain in terms of inheritance that in an animal you can define the basic animal class speak, or something that produces sound through the mouth. Okay, so you can define some function speak, but this speak, it will be different for each of the animals because their speaking sound is different. Okay, so in object-oriented programming, like in zoo management, what you'll be doing, an animal class, a dog class, a monkey class, or a tiger class, all of them will have a speak method. Okay, I think the basic animal will have speak. All of them inherit that basic speak method. Okay, but all of the implementations will be different. Okay, all of the speak method will be different. We're just telling, okay, the basic animal, it has to have speak. So tiger has to inherit the speak function. Dog has to inherit the speak function, but inside the dog class or inside the dog object, the speak, the sound will be different. Okay, right. When in your animal management software, what will happen when the dog will bark, the sound, and when the tiger will bark, they will sound different. Okay, so when you'll be writing the tiger object or when you'll be writing the dog object, you have to implement the speak method. Okay, then you have to use the speaker to make the sound, and you have to create a different sound for them. Okay, so basically it is the speak method, but the outcome is different. So it is calling that polymorphism, the same thing having different functions. Okay, another thing is that this plus, we know that it adds to numbers. Okay, but it can also do, it can add two different strings into one string concat, or it can do number addition. So the same operator, it is providing different functions or different functions. So this concept is called polymorphism, and I think that it is important in object-oriented programming, because you see that this speak is going to be different for different animals. And for aircrafts, I think it can also be different. The same function, it can have a different effect through the missile. Okay, different aircraft, different fighting aircraft can have this different, this same method, but the way they will throw it, or how far it will go, where it will go, or how it will be projected, it will depend on the design of the aircraft. On the surface, it is the same function, but they will work differently. But in terms of design facilities, what we are doing in the basic aircraft object, we are defining that, okay, for all aircraft we have to have a turn left or turn right or throw missile functions. We are telling that we have to have it, but to define the different aircraft, different types of aircraft, we are using the same thing but providing different functions. Okay, so this concept is called polymorphism. It is also required in object-oriented programming, and I think similar concepts come. The related concept is overloading and overriding. Okay, overloading and overriding. Overloading is that what I can say, the name will be same, but based on some other stuffs, it will work differently. Okay, I think it is just a property of the class or object, whatever you say. But in your, if you try to do a paintbrush program, okay, so the pen object, you can consider the pen object there. I actually wrote the paintbrush in one of my course assignment. The paintbrush related software, I once made it. Right. In the pen object, there can have a draw method. Okay, when someone moves it, it will draw something. Okay, and it can have the basic draw method that will draw whatever the user draws, but it may not take the width of the line or the color, or it will fill it or not. Okay, and another type, maybe you can define some properties, color, width, fill equals to true. So you are calling the pen objects drawing method.
So the actual pen is the method?
Yeah. Pen is the object.
Object.
Yeah. Draw is his functions.
Functions.
Yeah.
And then the different drawing.
On the different drawing.
So this is drawing method for color,
Yeah.
drawing method for
Yeah. Yeah. What I'm telling that this overloading and overriding, they actually apply to methods or functions of objects. Okay. Overloading is telling that different functions can have the same name functions for them, that draw with color, and fill it. You could define different function names, but that's inconvenient. Okay, then the programmer, he has to memorize all the functions the object provides. But I think one of the good design principle is you have to hide details of the object from the programmer. Okay, so whenever he wants to write the program, he does not have to memorize sum. He can write based on minimum information. So he knows that okay, the pin object will have a draw method. Now how it will draw, it will depend how the programmer supplies. If he supplies the color, then it will use that color. If he does not supply the color, it will not use the color. If it supplies the width, the line will be that kind of width. If it says that okay, the fill will be true, then if it is a rectangle, it will draw it and fill it. It depends on the programmer. The program is controlling okay how the drawing will be done, but the object or class is not controlling the programmer. If there are 15 different methods in the class, draw with color, draw with width, draw and fill, different methods, that the programmer has to remember all the methods. So by providing overloading, you are just giving a better programming or designing concept. And overriding, it is actually the stuffs we have covered. Right? Speak function, that we are telling that for basic animal, speak just some default sound. For dog, it will be another sound. For tiger, it will be another sound. And for dog, I think for different type of dog, it can be one more time different sound. Okay, so in the animal, in speak, you define the sound. In dog, you define another sound. In puppy dog, you define another sound. So what is happening? Dog is inheriting animal. Okay, puppy is inheriting dog. But still, we are rewriting the speak method in each of the different classes. Okay, so this concept is called overriding. Okay, when we are using inheritance, but we are rewriting the speak method or rewriting the method, that concept is called overriding. Okay, but if we don't rewrite, then what will happen? If we don't rewrite, then it will get the method of the parent class or parent object. Okay, if you don't define a speak method under puppy dog that inherits dog class, what it will get? It will get the same sound the dog does. Okay, so if you don't define it in puppy dogs, it will get its parent objects functions. Okay, so that concept is called overriding. So I'm just trying to say dog, it can be different type of dogs, puppies, lassie. Okay. And another concept is encapsulation.
That busy at night.
Everybody is busy with themselves. That's good.
Sunset has the glossary and has all the different terminology.
Yeah.
So straight from the Sunset website. That's good.
You can find it here. Okay, all the stuff that we are talking about. Some of these stuffs will be here, but some are basic concepts you need to know before knowing these. So you can see it here. Okay, one of the concept is encapsulation in object-oriented programming. Okay, I think it's nothing. I think we are telling that we are identifying objects and we are defining properties or variables associated with that object. And also what do you want, as we are trying to do programming in terms of objects, so not in terms of variables, we don't want to give access to these variables to outside, to the user or to other objects. Okay, we have to say, okay, this is the object. You have to interact with the object, not with any properties with the object. Okay, this is the basic concept. So this is actually the encapsulation, hiding. We are hiding the variables on the surface of object concept. Okay, so this concept is called encapsulation. To the outward, book is the concept, not book title or book author. They can't directly access book title or book author variable. They can use some methods to get the information about the book title or book author, but they will not be given direct access to the variable of the book. So this concept is called encapsulation. And what is tight encapsulation? Tight encapsulation is you have to maintain it strictly. Okay, you have to maintain it strictly, that you will not allow other people to access those variables outside the class. Okay. But in some cases you may need to do it, but still it's not recommended unless you have any other way, then you can do it. But so okay, as you're telling, tight encapsulation is expected in good object-oriented programming design. Cohesiveness, this is another concept. It's related to tight encapsulation, very related. It is just telling how cohesive is the class. All the variables you have defined, or all the properties or functions you have defined, all the events you have defined, are they really represent the class or not, or how well they represent the class or object. That concept is called cohesiveness. Okay, so let you have defined a dog class, and you have written a function that what I can say, is very unrelated function. Okay. Okay, I think that you have defined a dog object, and you are telling that you are writing a function like through ammunition. It is not related to dog.
Through ammunition?
Yeah, through ammunition or through something. Okay. It does not define the dog or its activities. Maybe it's doing something else, or maybe you have defined the dog and then you are telling hunt deers. Dog does not hunt deer. Okay, so your definition of the function, it does not relate to the dog. I think I'm just telling, maybe my examples are not that great, but the main concept is this, that you have to see the functions you have defined or the properties you have given to the object. They define the object itself. They are not far from the object concept. As I saw, deer, hunt deer or kill a deer, it's not the activities related to a dog. It can be activities related to a tiger. Okay, so how well they define the object? This concept is called cohesiveness. And loose coupling, that is one another concept in object-oriented programming, and it also expected. Okay, tight encapsulation, it is wanted. Cohesiveness is also wanted. It's a good design principle. Loose coupling, it is also expected in the object-oriented programming. I think what it tries to say, that objects should not be dependent on each other much. Okay, so one object should not contain another object. think if we define a good object-oriented programming, a good design, in good design we'll be able to identify objects separately or complete discrete entities or completely not much related entities. I think that's the better way design. But if you see that one object is using the other object and other object is using another object, I think in that case it's not a good design. Okay, I think you will know it when you will actually write the software. I think if that is the case, one object is using another object. Okay, so in that case the operations or functions that will get more complicated. Okay, if A and B two class, okay, if A contains B, just A contains B, B does not contain A. I'm just telling that A is a class, B is another class. Okay, and I'm telling A contains B. That means B is a variable under A, or B is a properties of under A. But A is not a variable under B, so we can define it as a loose coupling. If none of them contain one another, that's a very loose coupling because they are not dependent, but still in many cases this can occur, this may be required. Okay, but if it happens A contains B, B contains A, that's tight coupling. Okay, and that's a bad thing because in that case it's not defined where you will keep the interaction result between A and B. Okay, A is containing B, B is containing A. Yes, some loop and deadlock kind of stuffs. So you don't know where you are keeping the status. Okay, but in this case it would more or less define A contains B, so the interactions results you can find mostly in A. Okay, the interactions result of between A and B, you can find it in A. There is a certainty, but here it's confusing, so it is not expected. Okay, but loose coupling, as I told, it's expected. It's a good design. If you require, you can do it. And another thing is, if it is that no object is depending on another one, that's fine, that's fair enough. And I have given another resource here. I think it's a previous version of the Java. Okay, sorry. Okay, I just thought that I'm copying another resource. Okay, you can also take a look at this. Okay, this is tight encapsulation. What does it mean? And what is the benefits you get? Okay. Composition, it means one object contains another, or those kind of stuffs. And this is the generalization. Okay, I think I need to, before showing this, maybe I have to tell you some other concepts as they are. Let's see. Here they are telling to understand is a relationship and has a relationship. Okay. Is a relationship, what does it mean? If you, from our previous talking, the stuff we talked about in the inheritance, we can say that dog is a animal. Okay, puppy is a dog, or puppy is also an animal. So thus the relationship is a relationship. Okay, the relationship is a relationship. Okay, and another relationship is has a relationship. Right? It is the has a relationship. A contains B. That means A contains B object, A object contains B object. This is called has a relationship. Okay, I think in original exam, in SCJP exam, what can happen that they can give you some code and they can try to identify which one is true, which one is false. They will say that A contains B, or A is B, or B is C. You have to identify which one is true, which one is false based on the code they will provide. Okay, so the main thing is it is about inheritance kind of stuffs. Or I think I did not tell you yet the interface concept. Inheritance and interface, it maps to is a relationship. Okay, but if one object contains another object, that will go for has a relationship. Okay, they're trying to explain that here is a relationship. Pet dog is a dog, dog is animal, cat is animal, show dog is a dog, is animal. Okay, and they're telling this is specialization, this is generalization. It represents, animal represents all of them, but this pet dog, it does not represent all of them. It just represents pet dog. It does not represent cat. So it is a special case of animal. But this animal, it is a generalization of all animals. If you read this, you will understand more of the what is a relationship or what is has a relationship. Just go through this material and has a relationship. They are telling a car has a engine, a car has a battery, a car has a tires. What you can do in your software, you can write a tire class, tire object, you can write a battery object, and you can write a engine object. So what will happen? The car object, it will have some tires, some batteries, and the engine. So the relationship has a relationship. It can go further. A car engine, what it will have? It will have a combustion engine. You can define combustion engine as an object, or it will have some other gears or motors in the system. So you can define all those objects independently, then combine them into car engine. So you can say car engine has a combustion chamber, car engine has some piston, car engine has some motor, car engine has some gear. Where gear, combustion chamber, piston, all of them will have different objects. Okay, so this has a relationship. Overloading, overriding, that we have talked about. So method overloading, you can read it from here. That, as you told, this is a class. This is another class that is I think this extends, it means inheriting. Okay, extends camera, it means it is inheriting camera. In our case, what we could say, dog extends animal, puppies extends dog, Lacey extends dog, pet dog extends dog. Okay, so in that way, it is the inheritance. Overriding is, you see, there is a function here, still you are defining another function here, and we are defining it in the new way. So it is called overriding. Okay, but if we are not defining this shoot here, then this SLR camera, the shoot function should be this one. It would be working in the same shooting like this. But I think basically SLR camera shooting and normal camera shooting are different. So you have to define it in practical application. You have to define it in new function. So practically you have to go through the overriding. The constructor you can read, but I did not come to this point yet. Okay, I think the overridden concept, the concept applies to methods, but if it is done with the variables, if the variables are redefined in the child class, then the concept will be shadowed. Then if in animal class there is a variable xyz, if in the dog class if we again declare xyz variable, then the concept will be known shadowing, not overriding. But for the functions it's overriding. So this is the one, you can just read this chapter. Is about J2SC 5, but the recent version is J2SC 6. Okay, but still I think conceptually it will be similar, but there are some differences in terms of implementation or coding, but conceptually it's similar. I think what does coupling mean and cohesion mean, you can go through it. I explained you, I think it will be a similar thing, just to get better understanding you can read this book. This is different thing. Okay, and another thing is here on this top. Okay, I did not come to this point yet, but you can find these concepts in this chapter also. Okay, these are the some stuffs that are mentioned there, and you can edit it from here. Okay, now one thing we are left with, interface concept. It is also an important object-oriented concept. What we are telling, interface applies to a class, and I think in practical case how it can help. Let me see an example. Okay, basically what interface will look like. I think I need to shut down. Okay, interface, that in a real class or real object, what you will be doing, you will be defining all the variables and the functions. You will also write code for the functions. Okay, interface will look like similar, but it will have only the name of the functions. Okay, but it will not have any implementations. It is just telling it is an interface to this object. It defines what the object is, what are the method is, but it does not provide you any implementation. And why it is important? That for iPhone, Apple has developed the iPhone. Okay, but other companies can develop applications for iPhone. Okay, but to be able to write applications for iPhone, other companies need to know how the iPhone operating system works, or how the iPhone system internally works, or what are the different hardware modules, how to interact with those hardware modules. They need to know in details. But Apple will not release everything to the third party. If they release everything to the third party, then they will be making their own iPhone. Okay, but still to be able to provide good applications to the users. Also, it's beneficial to Apple that if people develop applications for iPhone and people gets interesting application for iPhone, people will buy iPhone more. So what iPhone will want, Apple will want that other third parties, Apple will allow them to write applications for iPhone, but still it will not give everything the third parties. So what it will give? It will give some interface to the other third parties. So it will say, okay, in iPhone we have a hardware, this does this and this operations. Okay, so it will say, okay, this is the hardware device, this is the interface or class for that hardware device, and it has this and these functions. So you can write your application will do some of your work, and if you need to implement and use the functions of what iPhone already does, you have to call this function, you have to pass this kind of parameters, then it will work fine. Okay, so what the third person is getting, it is getting some different interface classes. Okay, so third party is knowing, okay, these are the different interfaces iPhone has, and this is the function with this interface, and it can do this. So for my application, if I need to develop a function that we have to use this function, just have to call that function. So when that application will be deployed in iPhone, what will happen? From the third party application, when you call that function, it will execute the original implementation that is already residing in iPhone device. Okay, so interface comes into existence in that area. So you got the concept or not? You got the concept what is interface?
Yeah. Yes.
So interface is basically you write classes and everything in your system. So I think some other third party, they want to write something for you. So what you can do, you can give them the interface. They will write their own applications, and if they need to use some of the functionalities of your application, they will just call those methods. But they just need to know what your methods are, what they do, what are the parameters they take. Okay, or maybe it does not have to be another interface or another third party. It can be the same company, just a different group. You are working in one aspect of the application, they are working on another aspect of the application. They just need to know the what you are developing, just from the surface. Okay. Maybe you are still allowed to give them the internal details, but if they want to know the internal details, how you implemented the code, they don't need it. Okay, they will just need the interface. In some cases, they may need to know to better understand, but through the interface concepts, it also reduces the interaction between different groups. It also helps to reduce the interaction between different groups. Okay, because not everyone need to know all the different stuffs. Right. In Visual Basic, what you can do, you can call a Windows file open object, or you can use a media object, or in your form you can drop a Internet Explorer object, and then it will work as a Internet Explorer. Okay, so I think you can consider it as an interface concept. Visual Basic has some interface of the Internet Explorer object, Internet Explorer application. So your object, your application is making use of it, but you don't know all the details, and you also don't need to know. Okay, so this is the concept. I'm not sure I have showed you or not. Maybe I have already showed you. Okay, I showed you this one. Okay, I think another concept that may be useful, package concept. Okay, package concept, it's just the packaging of the classes. Okay, it's just the grouping of the classes. What I can say, right, package you can see, as I am telling that it's just a grouping of the classes, and you can group them and you can put it in some folder, okay, some directories. And another concept is that has a concept, A contains B or B contains A, whatever you say. If you say that A class contains B class, then B class has to be in the same folder. Okay, I think it's not absolutely true. I'm not sure I have activated this. Okay. I'm just telling, when I say that A contains B, then B has to be accessible by A. If they are in the same folder, it will work. Okay. Or if they are under the same package, it will work. But if they are not on the same folder or same package, if it is in the some other package or in some other grouping, you have to identify that. Okay. You have to tell that B contains in that folder. You have to say the package name. And I think what I can say that here we can see all of them as a package. Okay, this is the default package. In the hard drive, if you see, all these files are kept in the same folder. All these files are kept in the same folder. All these files are kept in the same folder. So you can think that if these were all classes, then they belong to the same package. And if they were or in the same folder, all are classes, then they belong to the same package. Okay. How to name the package? I'm just telling net a folder just defining a class, say animal. So you see this is the animal class, and by default this is what is telling package net.just.etc. So you can define a package name here. Okay. So public class animal, and it belongs to this. But if you give it the name com.net.just.etc, there is nothing wrong. You can give the name like this, but what will happen if you compile this class, it will not be in this folder. It will try to keep it in a folder like com.net.just.etc. Under source, it is a folder in the hard drive. Under source we have net folder, and under net we have just.etc folder. But if you compile it like this, by giving package name like this, what it will try to find a folder named com under src, and then net under com, and then just.etc under net, and then it will keep the class file there after compilation. Okay, so it's the default practice or good practice is you should keep the package name according to the folder name. Okay, and you also need to create the appropriate hierarchy of the folders so that it makes sense. Okay, so based on the operation and based on the object, you need to create the hierarchy of the folder and keep the classes in the right place. Okay, so what I am telling that net.just.etc animal. Okay, I can define another class here. Dog. Okay, then what I am telling animal A. Okay, I'm just telling class dog has animal A. As they are in the same package, it's okay. Both of them should combine. I think maybe where is the build project? Okay, I usually use this one. Folder you will see animal.class doc.class. Okay, but if you try to say let under net folder just UFM new class just aircraft and try to write aircraft, sorry, okay, I think I need to come this way, aircraft AF. So you see a cross sign, aircraft cannot be resolved because this class is under net.just.etc package, but aircraft is under net.ufm package. Okay, but what you could do, import net.ufm. You're just telling you can bring all of the classes under net.ufm .star, so there is no cross here. Okay, if you write I have removed and there cross sign again came. Okay, you're explicitly telling import this aircraft class, so it works. Or we can say star any of the classes it can bring. Okay, so that will also work. I think another thing is you have to be careful not to use this always, because if you import some of the big libraries but you need only one or two classes, then what will happen? Your program will be big and the compilation time and those will be bigger. So if you just use one or two classes from a library, what you have to do, you can just write 2 or 3 statements, 2 or 3 lines just to import those explicit classes, not the total library. Okay, so this is the concept of packaging. Here and another concept is jar concept. Okay, jar concept is, I think it is kind of zip file, not exactly zip file, just it can combine all the class files and it can create one jar file. Okay, right, I have defined 2 packages here, net.just.etc, net.ufm. It can have 100 different classes in it, so there will have 100 different files for each of them. Okay, now if another application tries to use these packages, you have to copy all those 100 different classes or 200 different classes to that application. Okay, and you have to keep it somewhere so that that application can access those things. That can be one approach, and another approach can be you can combine these 2 packages into one jar file. You can just supply the jar file to the other application. I think it's for convenience. Okay, what it will do, the jar file will, if you just jar file, it will create one kind of zip file. If you unjar it, you will be able to see all the classes again. Okay, I think the software you use to unzip, the same software can be used to unjar. I actually use the WinRAR software to unjar, but WinJar will not help you to create the jar file. You have to use Java jar command to create it, or there are some other ways to create. Maybe I can show you sometime, because if I try, maybe I need to organize some other stuff to make it work. Maybe I can prepare it and I can show you that it will be better. Okay, and class path concept, I think I can use here telling that it has an aircraft, though practically impossible. Okay, we cannot resolve it. And how do we do it? We did importing. Okay, but we could do one more thing, defining aircraft class in the class path. Class path is just a Windows system variable where you can keep the path of all the classes. Okay, when you compile a Java class, it will look into the classes, class path places for the unknown classes. If I try to compile it, what it will try to find aircraft class in the class path variable places. But if it finds that, it will not show this cross sign. How do we define the class path? In my computer properties, environment variable, I think you can define it here, class path. Okay, you can edit. This is some jar file, but what you could do, you can give the complete path, I think the folder path from C drive to the aircraft class, then it would be finding it. Okay, that's the concept. And this is the specific to user, this is the specific to system. If we define it here, all users will be able to use the class path variable. If you use it here, only when you log in as a site in this computer, you will be able to use it. But if you use Linux, I think you can also do it from the command line. Set class path, you can define the class path here, but it will work as long as this window is active. Okay, when the window is closed, then it will not again work. But if you put it in the environment variable previously showed, then it will work. And in Linux, it is also similar. You have to set class path, and then you have to use the export command. Okay, if you set and then export, it will work, and that is also temporary, that's not permanent. For permanent, what you have to do, I think there are some bash files or some profile files in Linux. You have to define class path in those files, then it will be permanent. Okay, so you have to take a break.